Okay, everyone, we are in our third section here. We're looking at, it's actually recursive formulas, but we're going to start off by seeing what explicit formulas do and then compare them to the new thing we're going to learn. Alright, so explicit formulas, this is where it's totally clear that you can find the nth term, whatever term you want, the 1000th term way down the road by just plugging in that index number, the number of term it is. So the 1000th term, we just put in 1000 there and we get it. So just to get a feel for the first like 4 terms of this sequence, plug in 1 and you get 1 times 4 is 4 plus 20, so we get 24. Plug in 2, you get 8, so it's 28, and so on, 32 and 36. It goes pretty quickly. These are just going up by 4. This is that really simple arithmetic. Okay? And this one is a geometric pattern where we're just putting in a number n, 1, 2, 3, 4, and then working it out. If I put in 1, 1 minus 1 is 0. 2 to the 0 power is just 1, and 1 times 1/4 is 1/4. When we plug in 2, 2 raised to the 2 minus 1 power, that's just 2 to the 1. That's 2. 2 times 1/4 is 1/2, and so on. And when I put in 3 there, 2 squared is 4. 4 times 1/4 is 1, and then it's going to double. I'm just multiplying by 2 each time. That's our common ratio multiplier. And so that's going to keep going up. If I wanted to go to the 1000th term, I could put in 1000. Now that would be a really huge number. Your calculator would sort of max out. But you could go up to 10 or 12 or 14 or something like that for sure. And maybe up into the 20s. You can give it a try. Alright, for third pattern here, this is geometric. Okay. This is a bit of a hybrid. It's actually called a figure number pattern, but we'll see why maybe in a minute. But if I plug in 1, 1 minus 1 is 0. 0 times n is, or 1 times 0 is 0. So my first number there is 0. If I plug in 2, 2 times 1 is 2. 2 over 1 is 1. If I plug in 3, I get 3 times 2. That's 6 divided by 2 is 3. If I plug in 4, that's 4 times 3 is 12 divided by 2 is 6, and so on. And I get that pattern. If you notice this one here, if I do carets, I get 1, then 2, and then 3, and so this is going to go up by 4, and I would then get 10. All right? You've actually seen that pattern before. That goes down to our pizza cutting problem, or a handshake, I think, problem. All right, so these are what explicit formulas are, where we're given a totally clear formula and we find each one term by plugging in that n number, that index number. All right? Well, recursive formulas are a little bit different. Recursive formulas are a little bit more organic, and that is that they sort of grow like a plant might grow. So we need a seed to make that happen. We need 2 things. We need to get it started, and then we need a rule to help it grow. Okay? For growth, maybe. And by growth, it could be shrinking, but or a rule for change, maybe, based on the earlier numbers. All right. So if you look at this one, our seed number is going to be our first number. Sometimes we only need 1. Sometimes we need more than 1. What do I need to do? I just need to take and add 4 to this. So the rule is you're going to start with 24. And then how do you get to the next term? That's all we care about in our recursive formula, is how do we get to the next term? Well, we add 4. So the way we do that, we'd say a sub 1, our first term, is 24. And then a sub n, that's any particular term based on the terms before. So in math, what's the term before a sub n? Well, it's going to be a sub n minus 1. That's just the term wherever we are. This is the term before it. If we're talking about the 10th term, well, we take the 9th term before it, and then we just add 4. So this is the entire recursive definition of that sequence based on a starting point and the rule for it to grow. Take the preceding term and add 4. Now stay away from actual numbers. Don't put down 2, because that's only the way to find the second term. Stay away from individual numbers. Use that index number idea right there. Okay? So you can maybe pause me and think about how would you write this based on our recursive rules. What's the seed for that B sub n formula? and then what's the rule from getting from one to the next. Okay, so pause me. Okay, and then you're back, and we're going to do b sub 1 is our seed, and b sub n is our rule. All right, so what do I start with? I start with 1/4. That's usually the easy one. In fact, it's so easy people forget to do it, but without it you don't know where to start. You can't just take any old term and start adding 4 to it. What if it was an odd number? I'd never get those up there. But the rule is that I take the preceding number, b sub n minus 1, and then I just multiply by 2. And that'll get me there. So I start with 1/4 and I multiply by 2. All right. My c sub n and my c sub 1 terms, again, you can pause me and try to do this last one. How do I go from here to there? How do I go from there to there? How do I go from there to there? Well, that's perhaps hard, but I'll let you try to figure that out, and we'll be back.